Welcome students to today's lecture. We are still continuing with types of materials, and today we want to discuss and explore more about medium carbon steels. So medium carbon steels contain a carbon percentage of about 0.3 to 0.8%. It possesses having bright fibrous structure when fractured. It is a tough material and more elastic in comparison to wrought iron. It can be easily forged, welded, elongated due to ductility, and beaten into sheets due to its good malleability. It can easily absorb sudden shocks. It is usually produced as killed or semi-killed steels and is hardened through treatment process. Hardenability is limited to thin sections or to the thin outer layer on thick parts. Its tensile strength is better than the cast iron and wrought iron, but compressive strength is better than that of wrought iron, but lesser than that of cast iron. So this is a very important material because it resists rust, and the melting point is usually for 1400 degrees centigrade, and it can be used in regions where the melting point is below this 1400. It can be easily hardened, and it possesses good balance of strength and ductility. So generally, what kind of materials, what kind of products has this material been used to make? So it has been used in making railway coach axles. Also, it has been used in making bolts. It has been used in making connecting rods. It's been used in making key stock, used in making wires and rods, shifts and brake levers, used in making spring clips, used in making gear shafts, small and medium forging railway coach axles, used in making crank pins on heavy machines, used in making spline shafts, crankshafts, forging dies, set screws, die blocks, and self-tapping screws, as well as clutch brakes. So other than the applications, we have the ratios of these carbon steels, and the percentage ratio of the carbon inside the carbon steel will dictate where it should be used. So for the plain carbon steel having carbon content of 0.3 to 0.45% has been widely used to make these products. That is the axle, special duty shafts, connecting rods, forgings, machinery steels, spring clips, turbine, rotors, gear shafts, key stock, forks, and bolts. However, the plain carbon steels having carbon percentage of 0.45 to 0.6% has been widely used to make railway coach axles, crank pins, crankshafts, axles, spline shafts, loco tires. As well, the plain carbon steel having carbon percentage of 0.6 to 0.8 has been used in making the drop forging dies, die blocks, bolt heading dies, self-tapping screws, valve spring, lock washers, hammers, cold chisels, hacksaws, jaws of vices, etc. So another type of steel is called high carbon steel, and as per the composition, high carbon steel contains 0.8 to 1.5% of carbon, and this material find application because it possesses properties like high hardness, good wear resistance, and the spring steel is also high carbon steel. The temperature at which this carbon steel is hardened is between 200 to 250 degrees Celsius. However, during the manufacturing process, it can only be used or operated at low cutting speeds. So these steels are easy to forge and simple to harden, and the percentage of carbon states of high carbon steels. So for high carbon steels containing carbon percentage of 0.7 to 0.8% and possesses Brenner's hardness of 450 to 500 are widely used in making cold chisels, drill bits, wrenches, wheels for railway service, jaws for vice structure wires, shear blades, automatic clutch disc, hacksaw, etc. So the steel containing 0.8 to 0.9% of carbon and has Brenner hardness of 500 to 600 has been adopted in making products such as making rock drills, punches, dies, rail clutch discs, circular shows, leaf springs, machine chisel, music wires, etc. And steel containing carbon percentage of 0.9 to 1 has been used in making dies, spring keys, and shear blades. Those containing 1 to 1.1% of carbon used in making railway spring, mandrail, taps, balls, pins, tools, thread, metal dies. Those containing 1.1 to 1.2% carbon used in making taps, twist drills, thread dies, knives, etc. And that containing 1.2 to 1.3% of carbon is used in making files, reamer files, dies for wire drawing, broaches, saw for cutting steel. To perform good during cutting, the tool material should possess the following properties for its proper functioning. 1. A low must possess low coefficient of friction between tool material and chip material, must have ability to resist softening at high temperature, ability to absorb shocks without permanent deformation, sufficient toughness to resist fracture and bear cutting stresses, strength to resist disintegration of fine cutting edge and also to withstand the stresses developed during cutting in the weakest part of the tool. High hardness, that means tool must be harder than the material being cut. Students, this marks the end of our today's class. Let's meet again in the next lesson.